Everyone thinks the AI race is about Nvidia GPUs, electricity, and data centers. And yes, all of that matters. But one of the strangest bottlenecks in the AI supply chain is something most people only associate with party balloons. Helium. Not a new chip, not a new model, not some secret algorithm. A gas. The same gas people joke about at birthday parties is also part of the physical backbone behind advanced chips, high-capacity hard drives, and AI data centers. That sounds ridiculous, but it explains something important about the AI boom. The more advanced the technology looks on the surface, the more it depends on very physical, very fragile supply chains underneath. Most AI stock stories begin with compute. Nvidia sells the GPUs, cloud companies buy the servers, and investors watch the capital spending numbers. But AI is not only a compute problem, it is also a storage problem. Models need training data. Inference creates logs, users generate interactions, companies save checkpoints, compliance records, embeddings, backups, telemetry, and retraining data. Every AI system produces data exhaust, and that data has to live somewhere. Some of it goes into high-performance SSDs, but a lot of it still ends up in large enterprise hard drives, especially cold data, archives, logs, and massive data lakes. So the AI build-out is not just buying chips, it is also buying storage. Here is where helium enters the story. Modern high-capacity enterprise hard drives often use helium-sealed designs. Inside a hard drive, multiple platters spin at high speed. If the drive is filled with ordinary air, the spinning platters create more drag, turbulence, vibration, heat, and power consumption. Helium is much less dense than air, so it reduces internal resistance. That lower density lets manufacturers fit more platters inside the same drive, improve stability, and lower power use. This is the first surprise. Behind some AI storage systems, there is helium. The second surprise is that helium is not only a hard drive issue. High-purity helium is also used in semiconductor manufacturing, where it can support cooling, process control, leak detection, and other sensitive steps. Chipmaking is not just silicon and machines. It is gases, chemicals, specialty materials, logistics, containers, purity standards, and timing. If a key gas becomes harder to source, the impact can ripple through fabs and electronics supply chains. That matters because AI is already stressing almost every part of the semiconductor system. Advanced nodes are tight, CoWoS and advanced packaging are tight, HBM supply is tight, enterprise SSDs are tight, high-capacity hard drives are tight. So why is helium suddenly worth talking about? Because AI has turned technology supply chains into a reservation system. TrendForce recently described the AI competition as a supply chain arms race. The important detail is that major AI players are trying to secure entire chains ahead of time. Advanced wafer capacity, CoWoS, substrates, PCBs, HBM, SSDs, and other key materials. That tells you the market has changed. The winners are not only the companies with the best products, they are the companies that can get priority access to scarce inputs. Helium normally stays invisible. Nobody builds a stock market narrative around a gas. But if geopolitical tension, LNG disruption, transport constraints, or a major production hub causes supply pressure, helium suddenly becomes visible. One reason this story has teeth is geography. A meaningful share of global helium supply is tied to natural gas production and LNG infrastructure, and Qatar has been one of the world's most important helium sources. That makes the Strait of Hormuz and Middle East energy logistics more relevant to AI than many investors expected. A conflict near an energy choke point can affect oil, but it can also affect helium. And helium can affect chipmaking and high-capacity storage. And those can affect AI data center buildouts. That is how a physical supply chain turns into a stock market story. So which stocks connect to this? The cleanest storage names are Western Digital, ticker WDC, and Seagate, ticker STX. They are not glamorous AI model companies, but they sit behind a lot of enterprise storage capacity. If large customers lock up high-capacity hard drives years ahead, and if supply stays tight, these companies can have more pricing power than investors used to expect from an old hardware industry. Then there are memory and flash names like Micron, ticker MU, and SanDisk, ticker SNDK. They are tied to the broader storage and memory shortage as AI data centers consume more SSDs, NAND, DRAM, and HBM. Then there are the buyers, Microsoft, Amazon, Google, and Meta. If GPUs, HBM, storage, electricity, cooling, and materials all get more expensive, the cost shows up in capital expenditure, margins, depreciation, and investor expectations. The point is not that helium alone will decide the AI boom. The real point is that AI investors are learning to price bottlenecks. First GPUs, then HBM, then advanced packaging, then power equipment, then cooling, then storage. Now, even specialty gases and logistics are entering the conversation. This is what happens when a digital revolution needs a physical empire underneath it. The software can scale fast, the physical world cannot. But there is also a risk for investors. Every bottleneck story can become overhyped. Storage companies can rise too fast, customers can overorder, companies can overbuild capacity, and AI capital spending can slow. The story can be true, and the trade can still be late. So the interesting question is not only who benefits from helium and storage tightness, it is how much of that tightness is already priced into the stock. So when someone says AI is about chips, they are right, but they are not seeing the whole machine. AI is also about power, memory, packaging, cooling, storage, logistics, and, in one of the strangest twists of the boom, helium. The most advanced technology in the market still depends on old-fashioned physical inputs. The future may be artificial intelligence, but the bottlenecks are very real. And sometimes, the thing that slows down the world's most advanced technology is not a missing algorithm. It is a missing gas.